All right, good morning, good afternoon, everyone. We're looking at doing some more things with logarithms today. So we're going to look at combining logs today and using those to solve log equations. But before we do that, we're going to look at a little bit of review here, how we do logarithms without a calculator again. And then we're going to look at some questions that we may have had on the homework. Okay? So remember, if we have something like these logs here, if we don't know what they equal or what they evaluate to, we just set them equal to x. And then we use what we call a check mark. So we do 5 to the x equals 625. And then it looks like an exponential equation where we can kind of work with these. We want to rewrite this as a base of 5. So 625, we'll write it over here, 5 to the x. 625 is 5 to the fourth. And we can just get rid of the 5. And x equals 4. So this first logarithm here would evaluate to a 4. And it should make sense if we put the 4 in there. 5 to the fourth is equal to 625. Okay? So these ones we didn't work a whole lot with these because I don't have anything down there. It's an implied base 10. Okay? So if there's no number down there below the log, then it should be a 10. So set it equal to x. Check mark, so rewrite it, 10 to the x. Let's get rid of this stuff. 10 to the x is equal to 0.00001. And remember, it's best to rewrite these as a fraction to see what it'll look like. So we can leave this as a 10, okay, because 10 is a pretty good number to work with. There's 10 as a power. We can use 10 to get powers of things as decimals like this or like hundreds and thousands. So this is tens, hundredths, thousandths, 10 thousandths, 100 thousandths. So 100 thousandths. So how can I rewrite this as a power of 10? Well, this would be, if I want to get to 100,000, then that would be 10 to the fifth power. 10 times itself 5 times would get me to 100,000. So there's your 100,000. So since it's a fraction, it should be a negative 5. So 10 to the x equals 10 to the negative 5. And just like the things we did before, answer is negative 5. All right, so this evaluates to a negative 5. So this one's going to be similar to that. Rewrite it. 36 to the x is 1 over 6. And I hope you can guess that we're using 6's here, since that's a 6 down there, and this is 36, which is the power of 6. So this would be 6 squared is that 36. And then on the right is 6 to the negative 1. So we can take our exponents. 2x equals negative 1. And then solve for x. And you get x equals negative 1/2. And that's that log. Okay, one more here, then we'll look at some exponential functions down below. So 8 to the x is equal to 4. This one might be a little bit harder to see because you might want to try to do 2 times 4, but you can't do that. They have to be powers of something. And 8 is not a power of 4. So you want to think about smaller numbers than these. So we're going to go with 2's. So 2 to the 3, so 2 to the third is 8. And then 2 squared is that 4. So we can get rid of our 2's. 3x equals 2. X equals 2 over 3. So that log evaluates to 2 over 3. Okay? So fancy way to figure out logs without a calculator if you can't do that different base in there. So down below here, convert the exponential function into a logarithmic function to solve for x. What is the value of x to the nearest hundredth? So we have that equation there. All right. If we want to get this exponential to something that we can change to a log, we got to get rid of that 2. We have to get this by itself. Okay, you got to get the exponential by itself. So we're going to divide the 2 from both sides. And then we'll have 6 to the x on the right, or the left, excuse me. And then we will have 412,500 on the right. And then from here, we can convert this to a log. So remember, it's kind of like check mark with the logs, but we're doing it this way. So we'll have log base 6, 412,500 equals x. And then we can actually do this in our calculator. We're going to learn what's called change of base formula today. So you're going to take log of this big number here divided by log of the base. So log of 412,500 divided by log of 6. And if we put this in our calculator, we should get close to what we want, which is about 7.21636. So let's just say 7.216. And it says to go to the hundredth, so I got to make that 7.22. About 7.22. So if we put that 7.22 in for that x right there, we would get 412,500, or about that. Okay? So next order of business, we're going to look at a few questions that you may have had on the homework. So I have 38 and 45. So we're going to look at graphing those. So you could, since this is 1/5, remember the easy way. Well, I guess it's easy way if you have powers of 5 memorized. You just use powers of 5 in your chart. So we would use like a 1, a 5, a 25, and then a 1/25th, and then a 1/5 probably. And then these are all just powers of 5 that come from that. Okay, so a 1 would be a 0, a 5 would be a -1, 25 -2, 1/25th would be a +2, 1/5 would be a 1, and we graph those coordinates. That's kind of the harder way to do it, so I'm going to remind you of the way that we did it the other day. That's harder if you don't remember powers of 5 or see how you can do that. It's easy if you do. Okay, so we rewrote this as y. So y equals log 1/5 x, and then we check marked from the base. So check mark here to here. So 1/5 to the power of y is equal to x. And then since we switched this around, since things are backwards, we did our xy chart backwards, and we plug into the y. Okay, so then if you're plugging these into the y, 1/5 to the -2 is a 25, and then the -1 is a 5, 0 is a 1, 1 is 1/5, 2 is 1/25th, and that's where I got those numbers from. Okay, and then when we go ahead and graph this, we're going to have the shape that kind of goes like this. So 1, 0 is always the one that it goes through. 1/5, 1. So that'll be up here. And remember, I'm not going to see how close you get to that. I'm just going to be looking for something close-ish. And then 5, -1. And then your 25, -2 is kind of off in space. So we've got this graph right here. And then it goes up this way. So we have an asymptote at x equals 0. That's where it's never going to cross. I don't know if we need a domain and range, but we're going to do it here quick. Domain, x is greater than 0. Range, all real numbers. It's going to go up this way forever, and it's going to go down, swing down this way forever. So that is a log graph. So 45 is a little bit harder because we have all the extra stuff here. Okay, so y equals log 1/4 x plus 1 minus 9. So remember, before we can switch this around, we got to get this log by itself. So we got to move this 9. All right, so y plus 9 on the left, log 1/4 x plus 1 on the right. Now we can check mark, and we got to check mark and take all this stuff here. Okay, we're check marking from the 1/4, that's our base. So now switching it to an exponential looks like this. And since we check marked it, we get rid of the log by doing that. We're converting it to an exponential. So x plus 1 on the right. So then you have to move the 1 over, and then we're done. So I'm just going to erase that and move the 1 over. minus 1 equals x. So now from here, we are good to go to plug things in. And I'm going to do the chart off to the side here. And then you can go ahead and graph the coordinates if you want to, which you should. So remember when we did exponentials here, you always looked at the exponent, and then that told you what would be your middle number. Okay? We think opposite of this, that gets me my middle number for my chart. So we're in the y's, so my opposite of the 9 would be a negative 9, and then I need a negative 8, a negative 7, a negative 10, and a negative 11. So your graph, you're going to have some things kind of scaled on this because it's going to make it a little bit easier when you graph it. So let's see what happens when I plug this in. So negative 7 up there. 1/4 negative 7 plus 9 minus 1 equals x. So that would get me a 2 up here. So 1/4 squared is 1/16. 1/16 minus 1 is a negative 15/16. Okay, so then if I put that negative 8 in there, this would be a 1, which would be a 1/4. So 1/4 minus 1 would be a negative 3/4. And I don't know what these are as for decimals. This is like a negative 0.9 maybe, and then a negative 0.75. That one's easy. Okay, and then let's plug in the negative 9. So if I put a negative 9 in there, that'd give me a 0. 1/4 of the 0 is 1, minus 1, 0. Put those little squigglies there. Negative 10 would give me a 1, a negative 1 up there, which would give you a 4. 4 minus 1 is a 3. And then you can kind of guess that the next one would give me a negative 2, which is 16, minus 1 is 15. So this would be the XY table that you would use for your graph. Okay? So it's kind of shifted way down. And remember, if we're looking at transformations, this is going to tell me my horizontal shift, and this is going to tell me my vertical shift. So it makes sense that my Y values are down at negative 9. So if we wanted to do domain and range, we have x is going to be greater than negative 1 as my domain. And that's also going to be the asymptote. So x equals negative 1 is the asymptote. And then range is going to be all real numbers. Okay, so that goes with our graph. So this one's definitely more difficult. You won't have one that's this difficult on a test or a quiz, but you could have something where you're shifting one number around. You won't have two, like a translation up and down and left and right. You'll just have one of those, or you could have a number in front, which would be a dilation. Okay? So now is the time where you can finish those questions and turn in your homework, and then we will get working on the new stuff. So pause the video while people turn that stuff in, and then come back and we'll get rolling. Okay, so I mentioned we're looking at properties of logarithms today. So we will be combining logarithms into one. If you have several of them, we'll be able to use rules to combine them into one so we can simplify them and solve. So let's see what that looks like. So properties, they work similar to exponents. So if you think about these being multiplied, if I'm multiplying exponents, we're going to do addition with those. So it's really similar if you're multiplying two logs, or excuse me, if you're multiplying two things inside of a log, okay, we have this and this, then we can split it to two separate logarithms. One for each number inside of the log, or one for each variable inside of the log, okay? The base is going to remain the same when you split them. Okay, so that's important that you write the base down when you split them. So division, if you remember what happens with division, that would be subtraction of exponents, and it's subtraction of logs. So when I divide two things inside of a log, I can split them up with subtraction. All right, and then the last one is going to be like a power to a power. If I am taking this power to another power or this number to a power, then I would multiply the exponents. Okay, so this n, and you're going to see me do this a lot when I work through things, this n would bounce down in front of that log because it would multiply into that log. Okay, so it looks like this, where the exponent is multiplying in that log. And this could bounce up top here to change it back to this. All right, so these are the properties that we're going to be using to carry us through today's lesson. They're pretty much going to be the entire lesson, just bouncing around using these properties. So we have an approximate value of log base 6 of 5 and log base 6 of 8. We're going to try to split up this log and use our approximate values to get our answers. Okay, this one looks kind of obvious possibly how we would do this. Future ones, not so much. So how can we split this apart? Well, we're using division here. So we're going to use our properties that we have division. So log base 6 of 5 minus log base 6 of 8. And where do we get these numbers from? They're up here. So we would just plug in 0.898, because that's the approximate value for this, minus log base 6 of 8, which is about 1.161. And then you just put that in your calculator, and you get your answer, which is a negative 0.263. Okay, so let's try the next one here. So this one might not seem as obvious. So when you're working with these, you got to think of ways that you can break up 40 using a 5 and an 8. Okay, well 40, if I just kind of think of factor trees, this is a 5 times an 8. 40 is 5 times 8. I can break this apart using my multiplication properties. So what happens when you're multiplying two exponents? You are going to add. So we're going to split this apart using addition. And then we have these values again, 0.898 for this one, 1.161 for this one. We put those together, and we get 2.059. Okay, so you're just trying to use these numbers here, the 5 and the 8, to get this log to break down. Okay, you can also use a 6. Okay, so a property of logarithms, if you have the base matching the number inside, that just turns into a 1. Because remember, logarithms are going to give us exponents. So 6 to what power is 6? That's a 1. So that's another option if you need it, which we might later on. Okay, so go ahead and try these next two, see if you can figure them out using properties. So pause the video for a minute or two, and then come back to see how to work through these. All right, so this one right here, 64. Hopefully you saw that I can use that 8 a couple times to get 64, because 64 is 8 times 8. So we're going to use our multiplication properties. So log base 6 of 8 plus log base 6 of 8, right? Because that multiplication needs to turn into addition when we split it. And then we're just using the 1.161 twice. So 1.161 plus 1.161 gets us to a 2.322. This is one of two ways to do this. So we can also use our power rules here. So I'll show you this one with the power rule. So 125 is 5 to the third. So we can rewrite this as 5 to the third. And then remember I told you this 3 should go. We can bounce that in front. So it's like this, 3 log base 6 of 5. Then you can use your approximate value of log base 6 of 5, 0.898, and you're just going to take 3 times 0.898, which is 2.694. So really, We're just breaking these numbers down into factors, but we're using specific factors based on our logs that we're given. People that have the button that has the boxes like this, or you can put different logs or values in for logs there, are going to be somewhat reliant on this for this type of activity, but you need to be able to do this. So this is the kind of thing where I'm going to say you have to be able to do this without a calculator. So you'd have to show the steps to get to these. Okay? So next thing we want to do, we're going to kind of use our properties still and just break these logs apart. We're going to break them apart, called expanding on this one, and then we're going to condense on the next one. So this is two things multiplying inside here. So remember what we do when we're multiplying. We split them apart with addition. So log base 6 of 5 plus log base 6 of x. And that's all you got to do. Once you split them apart as much as you can, then you're done. All right? So this one, I'm going to do it in 2 steps because we have multiplication again, but we also have that power rule up there. Okay? So the first thing I want to do is split that apart. Log base 6 of 5 plus log base 6 of x squared. And now when you expand, you can't have any exponents. And you can't have more than one thing inside of a log. I would need a number. I would need this in a log, this in a log, and that exponent gets taken care of when I split those apart. So this, too, needs to go in front of that log. All right, so to finish it out, log base 6 of 5 plus 2 log base 6 of x. That is completed. So we split the logs up to where there is nothing in, or only one thing inside of them, just a 5 and just an x, and the exponents are where they need to be. Let's try a few more examples here. Okay. So here we have division with this one, and it's just an extension off the stuff up above. So we could just write pretty much what we had up above. Log base 6 of 5 plus 2 log base 6 of x. And then how would we take care of that y on the bottom? Remember, it works the same way as exponents. Division would be the same as subtracting. Log base 6 of y. So we're subtracting that log base 6 of y. Okay. So trying the next one, we're going to have 4 logs for this one. We need a log for the 3, a log for the x, a log for the 5, and a log for the y. So whatever bases you have in there, that you need a log for each base. Okay, and this is going to be log base 7 because we have the little 7 down there. So I'm just going to work through this, split it up one by one. So the 3, log base 7 of 3, the x squared, that 2 would come in front of the logarithm like we did up here. And it's multiplication, so plus 2 log base 7 of x. And now since I have 2 things on the bottom, I'm going to have to subtract that group. So kind of like this, subtract both of those. Log base 7 of 5 plus 3 log base 7 of y. And I can't leave this like this. If I want it expanding completely, I can't have a negative in front of parentheses because we have to take the negative and multiply it through the parentheses. So really, an easy thing to do is whenever you are dividing inside of a log, you're just going to subtract everything that's on the bottom because we're going to subtract both of these because that group would have a negative in front of it. So anything on the bottom, like this one, we're going to subtract both of those. We subtracted the y, we're subtracting the log base 5, or the log of 5 and the log of y cubed. Okay, you're just subtracting those. Next one, log base 3, and this square root is an exponent, remember, so this is a little tricky. That would be x to the 1/2. As an exponent. So we'll have 1/2 log base 3 of x, And then remember, everything on the bottom is going to be subtracted. So log base 3 of 2 plus, minus 3 log base 3 of y. Okay, and then we're done. That 1/2 is our exponent, and the 3 is our other exponent. So this is expanding logs. So going the opposite direction, condensing logs, we're putting these together. Okay, so this one I'll do 1 or 2 of these, and then you see if you can put them together on your own. So just using the properties backwards from what we just did. Okay, and there is no base here, so remember that's base 10. So you don't need to write a 10 down there, you can just leave it as log. So if I'm looking here, the things that are directly next to the log are what are inside of the log. So maybe it's easier to see if I put parentheses around those. That 3 does not go with this log. This 3 goes with this one right here. Some people get those confused. Like the 5 down here goes with this natural log, and the 4 goes with this natural log. Okay? So what I like to do on these first, numbers in front of logs, remember those bounce up top as exponents. So that 3 is going to move here to make it 2 to the 3rd. And I'll do this in a few steps here so you can kind of see what we're doing. So log of 9 plus, that'd be an 8, log of 8 minus log of 3. Now we're just going to go from left to right using our properties of logarithms to put them together. So plus turns into multiply, minus turns into divide. So it'd be log of 9 times 8 divided by 3, which would be log of 72 over 3, which turns into 24, log of 24. So this step from here to here is the main step for condensing. I guess this one right here would be step 1, and then this would be the main step for condensing, and then we just work with the numbers on the inside. So we just simplify down as much as we can on the inside. You do not want to leave it like this. You have to simplify all the way down. Okay, so let's try a couple more of these. So I'll do this one with you, and then you want to pause the video and give the next one a shot. So this number in front of that natural log, and remember this is like log base e. They work the same way as regular logs, it's just ln. That 5 bounces up top, this 4 bounces up top. So we got natural log x to the 5th, and I write it as a cursive L so it doesn't look like a 1, minus natural log y to the 4th. And now we can put these together. What does this mean? It kind of looks like a division sign. It's got to be a division sign. So natural log x to the 5th divided by y to the 4th. And I like to put those in parentheses like that. Done. One more. So remember, if you want to pause the video, give it a shot, and then look at the answer here in a little bit. So exponents bounce up top for all of these, and then we're going to put them together. So log base 4 of 2 to the 5th, that's the 32. And then we got log base 4 of x to the 7th plus log base 4 of y to the 4th. This is all addition, which means they're all going to multiply. They kind of look like an x. So log base 4, 32 times x to the 7th times y to the 4th. It's all of those together, just crammed together because we're multiplying with those addition signs. All right, so that's expanding and condensing and using log properties. All right, we got one more thing until it's time for a break. So we are going to evaluate log base 3 of 8, okay? So this is the things where we talked about before, where we don't know what it switches to, so we would set it up like this. And then if you actually wanted to figure out what this log would be, you would just plug in a ton of numbers. You'd kind of have an approximate value, plug in a bunch of numbers until you start to get closer and closer to 8, which takes way too long to do it by hand. So there is what's called the change of base formula. which will help us figure this out. Okay? So, and I did this in the bell ringer question. If we have something like this and we want to figure out what it is, we take log of the big number divided by log of the little number. And I'm talking script sizes here. This is like 12-point font. This is like 6-point font. So we're taking log of the 8 over log of the 3. And then you put that in your calculator. And you want to make sure that if your calculator gives you parentheses around the 8, you got to make sure you close it off. Otherwise, it's not going to work. Okay? So if I do log 8 divided by log 3, we're going to get about 1.893. So if you took this number and you put that in the exponent spot for a 3, you should get pretty much 8. If you do this in your calculator, you get 8.00185. And if you use the answer, you would get exactly 8. But we used a rounded answer, so we got pretty close to 8. So we can evaluate these logarithms to find exponents to get us to specific numbers using change of base formula. Okay? So now we're on to a break here. And I kind of got ahead of myself with the change of base formula. But if you would like to take a break, pause the video and come back in a few minutes. Okay? So, generic version of the change of base formula looks kind of like this. Okay? You're taking log of A divided by log of C. And then I know there's a B here, but the B is just going to be base 10 or E, so like natural logs. If we did this with natural logs, it would work the same. All right, and this is what we just had. We had log of 8 over log of 3. And we could also do natural log 8 over natural log 3, and we would get the same thing. Okay, we would get that decimal that we just had. So this is change of base formula. If you want to evaluate whatever log you want in a calculator, this is the way to do it. The people with the fancy log button like that can just throw the stuff in here, but here's again, they have to know what the change of base formula is. This isn't going to be a formula that I give to you on a paper or something like that because it's super simple to memorize. Log of the big number over log of the little number. Okay? That makes it beneficial to evaluate whatever log you want. So we're going to skip over these and jump to finishing and solving equations. Okay, so solving equation using properties of logs. The first thing we need to do is condense logs. So put things together. On the left, you got 2 things. On the right, you got 1. So we have to put these together. That 4 will bounce up top as an exponent. And then we have to think about our properties that we use. So remember, this minus is like a division. So we can put the x and the 5 together like so. X to the 4th over 5. And then we have log base 2 of 125. Okay? When we do this, if we have the same log on both sides, this is similar to our properties where you have the same base on both sides. We can cross those off. Okay? And that's only if you have one log on the left, one log on the right. If there's several, like we started with, you can't just do that. Okay? You can't just cross logs off like that because it completely changes the question. So we have to do it this way where you condense and then you can work with the question. So we have x to the 4th over 5 equals 125. And then we can just solve that like normal. Multiply both sides by 5. Okay, those will go away. We have x to the 4th, equals 625. And then how do we get rid of this? We got to take a 4th root. Okay, that 4th root cancels with that 4th power, and 4th root of 625 is a 5. Since this is an even index, this should be plus or minus 5. However, remember what you can have or cannot have inside of logarithms. You can't have negative numbers inside of logarithms. So that makes it back to just a positive 5. We don't need both positive and negative because it's a logarithm equation. Okay, if we were just solving something like this, then you would need both. But since we're plugging it back into logs, we're checking our answers. Okay, you want to check your answers for these to make sure that they work. A negative inside of a log is going to ruin the equation. Okay? So, next one. This one can take a bit of time because we have this, which is an exponent, going up here. All right? So what this is going to do, it's going to have to FOIL out at some point, which we could make it easier, but we're going to do it this way just so we can practice foiling. All right? So this log will divide the stuff inside with this log. So log base 3 x minus 2 squared over 6 equals log base 3 of 150. All right, those will go away. And now we have this equals 150, which right here, you want to get that 6 out of the bottom. So let's rewrite that out. So take both sides times 6 to get rid of that in the denominator. So 150 times 6 is a 900. And we're just going to FOIL this one out right here while we're working through this. So x squared minus 4x plus 4. And then remember, anytime we have an x squared and an x, that's going to give us two answers. So we'll have to factor by moving this over and then attempting to factor that. And we get 896 equals 0. So we need to find two numbers that multiply to 896 and add to 4. So they're going to be fairly close. Okay, so if we did like 20 times 20, that's 400. So 30 times 30 is 900. So we're getting closer with the 30. So let's maybe take out a 28 and see what happens. See if 896 divided by 28. We get a 32. So this is going to be 28 and 32. That's what we're going to use to factor, because the difference between those is a 4. So it'll be x minus 32, x plus 28, and our two answers are 32 and negative 28. And you can see right here, we put that negative in there. It's going to make it a bigger negative, so that is out of here. Don't want it. So answer is 32. All right, let's check out a couple more of these. So how are we going to solve when we just have 5 to the x equals 62? So remember, 62 is not a power of 5. So we're going to have to use some kind of fancy formula or something at some point to get the answer. So what you want to do, and I'll show you two ways to do this. We'll kind of revisit it again tomorrow. I want to check mark log base 5, remember that's the base of 62 equals x. Now, that fancy formula was called change of base. And we would take log of 62 over log of 5 to get an approximate value for x. Okay, so log 62 over log 5 is a 1.253. And that's approximate. All right, another way. So this is an easy way if you just want to, it's called exponentiate, or I just call check mark. You know, check mark it to get it to where you want it to be. Another way to do it, which we're going to hit more in the next lesson. So what you can do to both sides, remember we can multiply both sides by whatever you wanted to. You can divide both sides by whatever you wanted to, as long as you do it to both sides. So now log is like a new operator for us. So we can log both sides. So I would have log to the 5x equals log 62. And remember, we can take this now and bring it out front, which would be something like this. And if I wanted to get the x by itself, I would divide by log 5 on both sides, which would cancel out here. And you get log 62 over log 5, which is exactly what we did here. Okay? And I know this felt like way more steps than this did, but this is more helpful. This method is more helpful for solving general log equations. It's easier to remember if you just say log both sides. So log both sides, exponent down, divide things out, and we get our answer. Okay? So similar on this one. If you wanted to pause the video before we work through it, that's fine. We'll get started here. So we rewrite this, check mark it. Log base 3 of 17 equals x. Change of base formula says we do log 17 over log 3. Approximate that. So log 17 over log 3, let's go calculator, would be about 0.587. And I like to go to 3 decimal places. Okay, that's just a preference with logarithms. I think 2 is not enough. 4 can start to be too many, so 3 is a happy medium. Okay? Let's do one more of these. Okay, let's do one more round. We're just going to work through one of these because these are kind of meaty. We have an inequality here, and we're going to use the method of taking the log of both sides. Because if I didn't take the log of both sides here, you really are check marking with exponents, and so you're going to have a base and then an exponent and lots of stuff going on. This is where I said this method is the better of the two to just generally get us through things. Okay, so I'm going to log both sides here. Log 3, 7x greater than log 2, 5x minus 3. Okay, and now we can bring down our exponents. And then that 5x minus 3, that whole group comes down and you want to put it in parentheses. Okay, and now here's where you can continue. We can distribute this log 2 through here, which is the most accurate way to do it. The algebra 2 way that I would prefer that you all do it is you start just multiplying these numbers and you drag decimals through. So what I'm saying, I want to take this log 3, which is log base 10 of 3, so you can put that in your calculator, and this is about a 0.477, which I'm going to multiply by that 7, and we'll have that x there. So my decimal on the left here would be 3.34, and we have the x with it. Don't forget that that's a variable right there. That's not multiply. And then on the right, I want to change that log 2 to a decimal, which is 0.301. And then that's what I want to distribute. Okay? So distribute the 0.301 to both of those. And then that you're just working with decimals from here. Okay? It looks pretty terrible from this step and this step, but then if you just change it to decimals using your calculator, it's not bad. So times 5 is 1.505, and we have an x there. Times 3 is a 0.903. And then we just solve this like we know how to. So if we ever divide or multiply by a negative, then we got to flip our signs. Otherwise, let's just roll through it. So minus 1.505x, move the x's to the left. And we get a 1.835x there. And a negative 0.903 still on the right. So divide by this on both sides, and we should have our answer. So 0.903 divided by 1.835, and we get 0.492. So x has got to be greater than, not greater than or equal to, x has got to be greater than 0.492. And we could plug that in and check, okay? And most things are going to work in our exponentials when we're solving log inequalities, which we'll do tomorrow. Those you want to avoid negatives, okay? So this step right here is the thing to remember. So you want to change them to decimals. And that's going to help you get through these questions, okay? And you're just pressing the log button in your calculator. So that is 6.6 and 6.7, working with properties of logarithms to solve them. There is your assignment, and you can email me and ask me questions if you need some extra help. All right, so good luck. Thanks for watching.